Hello, kids. Sorry I can't be with you right now. I just had my baby boy, Grayson Robert Winsler. He's at the hospital right now, um, having some feeding issues, but I came home to let the dog out here, and I thought I'd record a quick lesson for you guys so you guys wouldn't be off track. Okay, so what you're going to learn today is the law of sines. Okay, and we're going to use the law of sines to complete any triangle we want. Now, we can use it for right triangles as well, but as you practiced the other day, we kind of know some ways to solve right triangles so we don't have to break this out. But first thing I want to do is I would like to show you what the law of sines is. Okay, so let's say I had any triangle you want, triangle ABC, right? Okay, and what I'm going to do is I'm going to show you how the law of sines works. So if you have triangle ABC and it's not a right triangle, you might say, well, I don't know how to solve that. Okay, I don't know how to find the missing stuff. Well, what you can do is use law of sines. And before I show you what the law of sines is, I want to show you how we can get it. Okay, so looking at this triangle, you might say, okay, well, we know it's not right because there are no, right angles here. Okay, well, what if I made like a little right angle? So I'm going to bring down this little line here, and you see how that's perpendicular right there. Okay, well, let's say I call that side x, right? So there's side x. Okay, now if this is side x right here, okay, I don't know if you remember how triangles work, but um, you got these capital letters, these represent angles, right? Well, you also have lowercase letters. So if you had like, let's say you had angle A here, this would be side A, and you usually put a lowercase a, right? And if this were angle C here, this would be a lowercase c, this would be side C, okay? We're going to be doing that a lot. So this one's side B, but I'm not going to do that right now. You'll see that in a second. But basically, let's look at this little triangle here. This one I formed right here. Say this was a right angle as well, right? You got this little triangle sitting here, right? Well, I could tell you a relationship between angle A, this x, and side C, okay? So if you're sitting here at angle A, right here, wouldn't you agree that the sine of angle A would be x over c? It'd be opposite over hypotenuse, right? So I'm going to write that statement. I'm going to say sine of angle A is x over c. Sine of angle A is x over c. And I can do the same thing over here, right? I could say over here, okay, look, if I wanted to give a relationship between this, and this, right? I could say, based on this little triangle here, right? I could say, okay, the sine of angle C is x over A, opposite over hypotenuse, right? Okay, so look, sine of angle C is x over A. Once again, sine of angle C is x over A, right? So look what I'm going to do real quick. These two equations, what I'm going to do is I'm going to solve them both for x, okay? So it's really easy. If you want to solve both of these for x here, okay, all you would have to do is on this one right here, multiply the a over, and on this right here, multiply c. So if I did that, watch this. If I took this one right here and I multiplied c on both sides, right, I get x would equal c times the sine of a. And over here, when I multiply, when I multiply those by a, I get x equals a times the sine of c. Well, the commutative, what property is that? Substitution basically says if x equals this and x equals this, then these two things would be equal to each other. The transitive property, I'm sorry. So if I set x equal to this and x equal to this, basically this would have no choice to equal this as well, right? So what I'm going to do here, I'm going to give myself some room. But now what I can say is that, once again, if x equals this and x equals this, I could say this equals this, right? So these two things have no choice but to be equal. So watch. C times the sine of angle A equals A times the sine of angle C, okay? And the cool thing is, if you look at this, this actually is the law of sines. Now, we actually say this a little simpler, okay? What we say is, okay, if I divide C over here and if I divide A over here, the law of sines basically says this. Instead of this right here, we can rewrite that. we can say sine of angle A over A equals sine of angle C over C. Which, and you could also have done it with that side B, but basically you could say sine of angle B over B, okay? This right here at the bottom is the law of sines, okay? So if you don't write anything else down this lesson, that's what you need to write down, okay? This is the law of sines, and all that says is this: the sine of any angle compared to its corresponding side, that ratio would be consistent over the whole entire triangle, okay? So sine of angle A over A equals sine of angle B over B equals sine of angle C over C. That is the law of sines. And what I'm going to do is I'm going to show you how we can use that to solve specific triangles, okay? Okay, this is the law of sines. So please write this down right now if you need to pause for a second, okay? And you could flip it as well. You could say A over sine A equals C over sine C equals B over sine B. But the important thing to remember is obviously these are angles, right? Because you take the sine of an angle and these are sides, okay? And I'm going to show it to you real quick. So watch. Let's take it back to last semester just for a moment. Okay, I'm going to pull out a 30, 60, 90 real quick. So let's just say this. I don't know. And I'm just doing a 30, 60, 90 just because we know those triangles pretty well. We should. Okay. So here's a 30, 60, 90, right? And what I'm going to do is I'm going to say this. I'm going to say, okay, this 30, I'll just call it a 1, right? Remember the hypotenuse is double that, right? And this one would be root 3 times as long. So if you look right here, you have a 30, 60, 90 in the sides, right? So I'm here to tell you that this relationship will be true the whole way. Watch this, okay? The sine of this over this would equal the sine of this over this would equal the sine of this over this, okay? So watch what I'm about right here, okay? The sine, watch this. The sine of 30 over 1 will equal the sine of 60 over root 3, which would also equal the sine of, what's that angle right there? That's right, 90 over 2. This relationship, this proportion, should be the same throughout this whole triangle, okay? So let's think about this real quick. What's the sine of 30? Go to your unit circle, right? The sine of 30, if you go to 30 degrees, the y value there is 1/2. So 1/2 over 1, right? Okay, equals sine of 60. Go to sine of 60, that's root 3 over 2, right? Over root 3 equals the sine of 90 would just be 1 over 2, right? I bet you anything, all those are the same, okay? So watch this. What's 1/2 divided by 1? Well, that's 1/2, right? Did you know if you do a keep change flip on that, the root 3's will cancel out, you'll have 1/2, and over here you have 1/2. See what I'm saying? 1/2 equals 1/2 equals 1/2. So that is the law of sines, essentially. So once again, law of sines, in any triangle you have, sine of angle A over A equals sine of angle B over B equals sine of angle C over C. That is the law of sines, okay? And I'm going to teach you how to apply that to solving triangles, right? So here's what we're going to do. Okay, so there are two types of triangles I'm going to teach you to solve today, okay? Two types of triangles, all right? The two types of triangles I'm going to teach you to solve are what we call I think I'll start with a AAS and an ASA, okay? So these are two types of triangles I'm going to teach you today, okay? What we call a angle side and an angle side angle, okay? And these are two types of triangles that you can solve with the law of sines, okay? And I'm going to teach you how you can recognize that. But what I'm going to do is I'm going to start off with an example here, okay? I think I'll start off with one of these, an angle side, and show you how you can use the law of sines to solve a triangle. So here's what your problems are going to basically look like, okay? So most of the triangles I give you, I'll just keep it simple. I'll call it triangle ABC, okay? Well, in triangle ABC, you're going to have angle A, angle B, angle C, side A, side B, side C. And drawing those triangles is going to be pretty important. So here's the information I'm going to give you. So let's just say, I'll erase this. I'm telling you it's going to be an angle side though, okay? So let's say you have this information. So let's say in triangle ABC, okay, we have this angle C, 97 degrees. Angle C is 97 degrees. Angle A is 63 degrees. And let's say C is 29. Okay. Now, I've given you two angles and a side. Okay. Now, I need to draw this to truly see it, but basically, here's what we're going to do. Triangle ABC, this is what we have, and the directions will be solve the triangle. Now, when they say solve the triangle, what they mean is they want everything that's missing found. Okay. So here's what I do every time I get one of these triangles. Okay. Or one of these problems. What I do is I draw a triangle. Now, I'm not, as you know, I'm not a big artist, right? So I just draw, basically, here's what I do. I'm not worried about it being drawn to scale or anything. I just draw the most generic triangle I can, and I go A, B, C, just like that, every time. I don't care if it's a right triangle, I don't care if it's whatever, obtuse, doesn't matter. I just draw A, B, C, okay? Now, I'm going to fill in this information, okay? So you see angle C is 97. So I put a 97 here, right? Okay. A is 63, so there you go. I got C is 97, A is 63, right? And it says side C is 29, right? So if side C is 29, what you do, you got to think about which one of these sides is side C. Well, if you're here at C and you go exactly to the opposite right there, that would be 29. So if you look at what I'm missing here, here's what I'm missing. I'm missing side B, side A, and then I'm missing angle B as well. Okay, that's what you're missing. Okay, so basically we have, look, we have 1, 2, 3 things we're missing in this triangle, okay? Now, we can't do the normal things we do with a right triangle, but we can use the law of sines here, okay? Now, I want to show you how you know this is a candidate for law of sines, okay? Here's all you got to know. Okay. There is an angle and a corresponding side here, okay? There's an angle and a corresponding side that match up, okay? Do you see how we have angle C and we have side C right here? You see how they match up? As long as you have one of those pairs, you can do the law of sines, okay? Now, I want to show you something very easy, okay? We said this is called an angle side. The reason we call this, watch this. The reason we call this an angle side is because you have two angles here, right? And a side that's not included between these two angles. What I mean not included is it's not like right dead in the middle, right there. If it was right here, we'd call it an angle side angle, okay? But this is called an angle side. Now, what we're going to do is we're going to solve for the missing pieces. Now, the easiest thing to do is solve for B first, okay? The reason that's easy is because you can just subtract from 180, right? So if I took 180 degrees, right, and subtracted 63 and 97, I'm going to do this in a different color. Basically, I can go ahead and do this. I can go ahead and say, okay, B is going to be 20 degrees, right? Okay. So basically, all we need to do is solve for these two sides right here, right? Okay. Well, it doesn't matter which one you want to solve for first, but here's the proportion we have to set up. Okay, here's what we're going to do. We're going to say, look closely. We're going to say, okay, first proportion we're going to set up is we're going to say the sine of 97 over 29, okay? Now, if you look at that, the sine of 97 over 29, that's angle C and side C, right? And remember, the law of sine says sine of C over C equals sine of A over A equals sine of B over B, right? Now, you got to pick which side you want to solve for. It's easy, okay? If you want to solve for this side, which is side B, right? Great, go for it. If you want to solve for A, go for it, okay? But it's up to you. So let's say I wanted to solve for this one right here, which is side A, right? This is side A. Here's what I do. Sine of 97 over over 29 would equal, look at this, sine of 97 over 29 would equal, watch this, the sine of 63 over A. See that? Look, the sine of this, or excuse me, the sine of this over this equals the sine of A over A, okay? And this is a very easy problem to solve because all you have to do here is cross multiply. So when you cross multiply this, here's what we do. We cross multiply, right? So we say 29 times the sine of 63 equals, let me give myself some more room there, I'm sorry. We say 29 times the sine of 63 will equal A times the sine of 97. Okay. 29 times the sine of 63 equals A times the sine of 97. Now, what are we trying to solve for there? We're trying to solve for A, right? So all you got to do, you see how it says A sine 97? You just take both sides there, right? You take both sides, you divide by sine of 97. And we can now solve for A, okay? So if you look right here, all you have to do is you literally type this in the calculator, right? So I'm going to type in my calculator. I'm going to type in, look at what I'm typing in. 29 sine 63, okay? So I just typed in 29 sine 63. So if you look right there, I don't know if you can see that. 29 sine 63, right? What am I going to divide that by? Well, I'm going to divide it by sine 97. So if I just type in divided by sine 97, you can type in that expression. Check it out. You can type in that expression just like this. Let me get you a little better shot. Okay, hold on a second. Let me see if I can focus it now. I'm sorry. Here we go. Okay, so essentially what happens is this. When I type in 29 sine 63 divided by sine 97, it's going to spit out A, okay? So make sure you're in degree mode, obviously, when you hit enter. But I got 26.03, okay? Okay, I got 26.03, and make sure you got that as well. But that's side A. So what I'm going to do now is I'm going to come over here, and I'm going to type in, or write in 26.03, okay? See that? Now, notice this. See how this angle 97 was bigger than this angle 63? Guess what? 97 has a bigger side across from it than 63 does, okay? The bigger angles have the bigger side. So I knew that 29 was going to be larger than 26.03 because 97 is larger than 63. So bigger angles have bigger sides, smaller angles have smaller sides, okay? Now, there's only one thing left to solve for, right? There's only one thing left to solve for. What is it? It's going to be this side B, okay? So watch how I'm going to set this up. See this proportion I just set up right here? Okay, watch this. I'm not lazy, I'm efficient. So here's what I'm going to do, okay? See how I had that sine of 29 or sine of 97 over 29, right? I'm going to keep that for the whole problem because that's a proportion I can count on. Okay, now, if I want to solve for B, right? You'll help me out. Here's all I have to say. I say sine of 97 over 29 would equal sine of 20, right, over B. And guess what? You can solve for B very easily, the same exact way. All you got to do is cross multiply. So watch what I'm going to do here. I'm going to say 29 times the sine of 20 equals B times the sine of 97. Okay, once again, look here. 29 sine 20 equals B sine 97. And all you have to do is divide by sine 97 on both sides. Sine 97. So if I did, once again, look at this. 29 sine 20 29 sine 20 divided by that sine 97, you will get B. Now, let's take a prediction here, okay? See how B is the smallest angle there, 20? I bet you anything this side is going to be lower than both of these sides, okay? So watch what I'm going to type in my calculator. I'm going to type in 29 sine 20 divided by sine 97, okay? So while I'm typing in, you guys type it in too. 29 times the sine of 20, 29 sine 20 divided by sine 97. Let's see if y'all can see this real quick. Okay, now when I hit enter, I bet you anything something lower than 26.03 comes up. So let's see. They have it. Focus for me. There you go. Sorry about that. 9.9. Let's say, I mean, we can say 9.99, but it's basically like 10ish, right? But there you have it. We just solved that triangle, right? Okay. Now, the cool thing is this. I'm going to erase everything else here, okay? But watch this. Here's how you can check your answers. Nolly, come here. Come here, Nolly. My dog just got bored of my lesson. Come here, Nolly. Come here. Come here. Did you just get bored of my lesson? Do you want to go outside now? Okay. You don't like the law of sines? She's a law of cosines girl. Okay, so what we can do to check this is basically just set up those proportions and make sure they're all the same. Okay, now obviously if you look at this triangle, the bigger sides have the bigger angles, right? 97 has that 29 across them, right? That's the biggest ones. And the smaller ones right here have the smaller ones across them right here, okay? But the way you can really check this is you can set up the proportions for the whole triangle and make sure they're the same, okay? So here's what we're going to do. Give me 1 second. You go outside. Get out of here, you old mutt. Here's what you're going to do, okay? I'm going to write 3 proportions. Watch this. I'm going to write sine of 97 over 20. Sine of 97 over 20, right? Equals sine of 20 over 9.99 equals sine of 63 over 26.03. And if you look at that, I bet you anything, all 3 of those ratios are about the same, okay? So let's check this out. I'm going to start with sine of 97 over 20. So sine 97 over 20. See that? Sine of 97 over 20. I hit enter. And there's the ratio I'm looking at. It's like 0.0496, okay? Now watch this. The next one, sine of 20 over 9.99. If we're correct, this will be, we'll focus first off. That will be about 0.05-ish, right? So if I do this, well, that's a little, that's not exactly, oh, well, I'm an idiot. Does anybody see my mistake here? That's how I know I'm wrong. See those 2 ratios, they're not the same. Now, I put sine of 97 over 20. It should clearly be, if you look at that, sine of 97 over 29, right? So let me correct that. Sorry about that, kids. This is why we check ourselves, okay? We are right. I just typed it in wrong. So look, I'm going to do this one more time. Sine of 97 over 29. This is the correct one. Sine of 97 over 29. See how it says like 0.034? Okay, now watch this. Sine of 20 over 9.99. Look at that. See how that's like 0.034 as well? Okay. And then finally, the other side was is a 26.03. So look, it was sine of 63 over 26.03. See that? Now if we're right, that should be about the 0.034 as well. And look. 0.034. So that is the law of sines in action. See how they're all the same ratio? That is the law of sines. Any triangle you want, sine of A over A equals sine of B over B equals sine of C over C. Okay, now, last thing we're going to do, okay? We just solved a triangle, right? So next one we're going to do, last one, we're going to do something called a ASA. Okay, an ASA. So put that in your notes. This is an angle side angle scenario. But ASA, I'm going to erase that, okay? But here's what we got. Same directions, okay? So look, in triangle, I think I can spell triangle. In triangle ABC, okay? In triangle ABC, let's say angle A is 63 degrees. Angle C is 101 degrees. And B equals 9. So we have an angle, and a side, right? Now what I want you to do, I want you to pause this real quick. I want to see if you can draw that scenario, okay? On your own paper, take a minute and see if you can draw it, okay? Well, if you drew it correctly, I'm drawing mine right now, okay? A was 63, C is 101, and B is 9, okay? Now yours might not look exactly like that, but it should be in the right spots, okay? Now, this is what you have, okay? Now, here's the question, okay? You might say, well, how, Mr. Windsor, how do I know that when I'm given that situation, I should use the law of sines, okay? The question you need to ask yourself is, do you have an angle and a corresponding side that match up? Okay, so you look at this picture, you say, okay, well, I have angle A, but I don't have side A, so I don't have that. I got angle C, I don't have side C, I don't have that. I've got side B, but not angle B. So no, Mr. Winslow, I cannot use the law of sines here. Well, I would say, yes, you can. Because angle B here, we can figure out. Okay, let's look at this. What's 101 plus 63, okay? Well, that would be 164, okay? How many more degrees are there in 180? Well, if you have 164 and you need to get a 180, that would be 16 degrees, right? 180 minus 164 is 16 degrees. Just making sure I'm not brain dead from staying up for 48 hours straight, okay? But there you have it, 16. Now that you have that, you see how you have angle B and side B there? You can set up a law of sines. So here's how are you going to set this up. You're going to say, okay, the sine of 16 over 9, the sine of 16 over 9 equals whatever other proportion I want to find, okay? So let's say you want to find C, okay? Well, the sine of 16 over 9 would equal, check it out, sine of 16 over 9 equals the sine of 101 over whatever this is right here, right? Okay. Do you think side C is going to be larger or smaller than 9? Okay. I bet you anything it's larger than 9 because 101 is larger than 16, okay? But think about how we solve this right here. It's just a proportion, right? So look, cross multiply. See this? I take 9 times that. I take C times that. So look, 9 times sine 101 equals C times sine 16, right? And if you just divide both sides by the sine of 16, you'll get your answer. So I'm going to type in my calculator. Check it out. 9 sine 101 divided by sine 16, just like this. Okay, and when I hit enter, this is what I get. Let's see, what does it say? 32.0, come on, focus for me. 3205. Okay, so I'm here to tell you, look at this. I'm here to tell you that this side C right here will be 32.05. Okay, 3205. which is larger than 9, right? Okay. Now, what's the last thing I need to solve for there? Okay, we have everything except for, look at this. We have everything except for side A. Okay, the side across from angle A, right? So here's what I'm going to do. I'm going to erase all this stuff. I'm still going to use, look, I'm still going to use sine of 16 over 9 because that's the original one I had, right? Sine of 16 over 9. But look, if I want A, I say sine of 16 over 9 would equal, let's see if I can find this, the sine of 63 over this, right? So I say sine of 63 over, I'll call it side A, right? See that? And just based on that proportion, look, I bet you anything that's going to be larger than 9 because 63 is larger than 16, right? So cross multiply, look, cross multiply here. So you have 9 sine 63 equals A sine 16. And all you have to do at that point there is divide both sides by sine 16. So divide by sine 16, divide by sine 16. See how those cancel out? And A would equal, check it out, A would equal 9 sine 63 divided by sine 16. Make sure you're in degree mode, right? I type it in just like this. And I bet you anything that comes up larger than 9, right? Okay, so let's hit enter. Boop. 2909. So look, 2909. There you have it. We just completed that triangle, okay? Now, here's the biggest thing you need to understand, okay? You always want to check your ratios, okay? So the sine, check it out. The sine of this over this should equal the sine of this over this should equal the sine of this over this, right? The bigger sides have the bigger angles. The smaller sides have the small angles, right? Okay. Would the Pythagorean theorem work here in checking this? No, it would not, because this is not a right triangle, right? But you could use the law of sines to check that out, okay? So that is your law of sines, and what we just did, we used the law of sines to complete two triangles, okay? One was a angle side angle, and one was an angle side, okay? So basically, in both those scenarios, you have an angle and a side that are both given to you that correspond, like angle A and A, okay? In this case, we had angle B and side B, right? That's how you know you can use the law of sines, okay? So tomorrow, what I'm going to teach you, I'm going to teach you how to solve an angle sides, I'm going to teach you how to do a side angle, okay? And just as you suspected, this is not going to be fun, okay? If it spells a bad word backwards, it's going to be a bad scenario, okay? So hold on to the edge of your seats, all right? But your goal today was use the law of sines to complete an angle, side angle, and an angle side scenario triangle, okay? And I will tell you this. Essentially, I'm going to ask you at some point in the semester why the law of sines works, okay? And you need to go back at the beginning of the lesson, and when I prove the law of sines, you need to check that out, okay? So, saying that, your homework, you'll have about a few problems solving missing stuff on the law of sines, and that's it. So I'm back to the hospital. Go check on my wife and my baby, make sure they're doing okay, and hopefully I'll see you sooner than later, okay? But keep an update. Subscribe to my YouTube. They'll all be there. I'll see you guys later, okay? Bye.